Okay, so we're going to use the three log laws that I'm going to write down in a minute to simplify first part A, log base 2 7 minus a half log base 2 3 plus log base 2 5. So when it says simplify, obviously it means write it in something that looks a bit simpler, but what it really means is we only want one term in the answer, preferably a single log. And part B is going to be 3 minus log base 2 5, which looks on the face of it easier, but it's a bit tricky with that 3. So if I just write down the three log laws that you need to know. Log base A xy equals log base ax plus log base A of y. So it doesn't work if your base is different, so just notice it's all log base A. But once you have this, you can use it for any A. Second law is just the opposite for division really, so log base ax over y equals log base ax minus log base A of y. Note that it needs to be that way around. It's x over y and it's log base ax minus log base ay. You need to, if it was y over x, then it would be log base 8y minus log base ax. It has to, unlike multiplication and addition, subtraction and division, the order that you do it in really does make a difference. So the third law, log base A of x to a power equals that power times log base A x. So incredibly useful law. One thing I should note, both of these laws, they go both ways. So you don't think that you can only transform an expression by going from left to right. All of these you can, if you have an expression that looks like this, you can turn it into this. In fact, for the first two, you're much more likely really to go from right to left than from left to right, depending on what you're doing, of course. And for the third law, you could use it probably, I'd say probably equally in both directions. So either moving a power in as a multiplier and moving a multiplier up as a power. It'll make a lot more sense once we see it. These are the three laws and we're going to use them for the rest of this question. So part A, log base 2 7, log base 2 7 minus a half log base 2 3 plus log base 2 5. So the good news is everything's already in the same base. So if you look at our A is 2 for all of this, so that's fine. Looking at it, you've kind of got a log of something minus the log of something else plus a log of something. So this half is an issue which we'll talk about in a sec. But you're already probably thinking first two laws, hopefully, because we want to end up just having one term in the answer. So because I know when I add logs together I multiply, and when I subtract I'm going to divide. I think one thing I will do, just as my next line, I'm just going to put the two positive terms together. So let's just say that equals log base 2 7 plus log base 2 5 minus a half log base 2 of 3. So we could already put these two, in fact we could already say that log base 2 7 plus log base 2 5 is going to be log base 2 of 7 times 5. Then what we can't do, unfortunately, is now do the division. We can't do it yet because this says a half log sum. If you just look at the third law, sorry, the second law, then to turn log of something minus log of something else into a single log, we can't have any multiplier other than 1 written in front of the log. So we need to do something with this half. And the way you deal with that half is you look at the third law, which says if you've got a multiplier in front of something, you can move that multiplier up. So we're going to go from right to left and move the half up as a power. So I'm going to say minus, and I'm going to move this half up there as a power. So minus log base 2 3 to the half. Okay, so if we tidy this up, well, 7 times 5 is 35 equals log base 2 of 35 minus log base 2, and 3 to the half we know is root 3. Put that in like that. Now we can use the second law, which says log base a of one thing minus log base a of another thing is a single log of the first thing divided by the second thing. So this is now log, still in base 2, of 35 over root 3. Okay, so that is sort of finished. You could potentially, rationalize that if you wanted to. I think from the point of view of a log question, I'll probably just leave it there. I'm not really testing can you rationalize surds right now. I obviously needed to be able to do it. I want you to be able to interpret and apply log laws. Right, part B, and this is tricky, but hopefully if you read the first bit of the presentation, you'll be able to rewrite this 3. So this says 3 minus log base 2 5. So we want this to be just one single term, so it's probably going to have to be a log in base 2, and we just want it to be one thing. So I can't apply any of these log laws at all to a non-log, so I need to think about this 3. So is there any way I can write this 3 so that it appears as a log, preferably in base 2? So that is quite tricky, isn't it? So I need something like log base 2 of something needs to equal 3, right? So log base 2 of what equals 3? So you've got a choice really. You can either just think, well, 2 to the power 3 equals what? Or I can just write 2 to the power 3. But seeing as it's such a simple number, I can just do this, look. So, and let's just have a think about what I've just written. So I'm saying log base 2 8 equals 3. So that's saying the power I need to raise 2 to in order to get 8 is 3. And that's because 2 to the power 3 equals 8. So what that means is, because I've just shown that log base 2 8 is 3, let's get rid of this box, then that means I can just replace this 3 with a log base 2 8. So I can write now log base 2 8 minus log base 2 5. So that's the tricky bit, and it is tricky, no doubt, but once you've done that, then really it just becomes a simpler application of the second law. So now I've got log base 2 8 minus log base 2 5, so I can say, well, that's log base 2 8 over 5 equals log base 2 of 8 over 5. So you could potentially leave it as 8 over 5, but seeing as it's quite nice numbers, you could say, well, that's log base 2 of 16 over 10, which is 1.6. And it just depends how you want to present numbers, really. I think 8 over 5 is okay, but if you like decimals, I will allow it this once. Log base 2 of 1.6.